The universe is dying, not someday in the distant future, right now. Every second that passes brings us closer to absolute darkness. Scientists just calculated the exact timeline, and what they found is terrifying. In 100 trillion years, the last star will flicker out. In 10 to the 100 years, black holes will evaporate into nothing. And in 10 to the 120 years, even space-time itself will cease to exist. 3 deaths, 3 endings, each more final than the last. If you're ready to witness the complete and total destruction of everything that exists, hit that subscribe button. The countdown starts now. Let's start with what happens first, the stars. Every star you see in the night sky is burning through fuel. Hydrogen fusing into helium, releasing energy, fighting against gravity's collapse. Our sun burns through 600 million tons of hydrogen every single second. It's been doing this for 4.6 billion years. It has enough fuel left for another 5 billion. That sounds like a lot. It's not. In cosmic terms, 10 billion years is nothing, a blink. Because here's what most people don't realize. Stars like our sun are middle-aged right now. The universe is 13.8 billion years old. Star formation peaked about 10 billion years ago. We've already passed the golden age. New stars are still forming. You can see them in nebulae like Orion, clouds of gas collapsing under their own gravity, igniting fusion in their cores. But the rate is slowing. The universe is running out of raw material. Hydrogen and helium, the fuel for stars, get locked up in dead stars, planets, and black holes. Less fuel means fewer new stars. Fewer new stars means the universe gets dimmer, year by year, century by century. The math is brutal. In 1 trillion years, star formation will effectively stop. The last massive stars, the blue giants that burn bright and die young, will already be gone. They only live a few million years. In 10 trillion years, even medium-sized stars like our sun will be exhausted. Red dwarfs, the smallest and longest-lived stars, will be the only ones left burning. Red dwarfs are survivors. They're tiny, dim, and incredibly efficient with their fuel. A red dwarf can burn for 10 trillion years. Some estimates push that to 20 trillion. But eventually, even they run out. The last red dwarf in the universe will flicker, dim, and die around 100 trillion years from now. And when it does, the universe goes completely dark.
No more sunlight, no more warmth, no more fusion reactions anywhere. Just dead stellar remnants drifting through an expanding void. White dwarfs cooling slowly into black dwarfs. Neutron stars spinning down, their magnetic fields decaying. Brown dwarfs that never ignited, frozen in eternal darkness. This is called the Degenerate Era. The age when normal matter still exists, but nothing shines anymore. Planets still orbit dead stars, galaxies still hold together under gravity, but there's no light, no energy, just cold, dead objects floating through the blackness. If any civilizations survive this long, they'll be huddling around the last dying embers of the last red dwarfs, watching the universe fade to black. But that's just the first death. The universe isn't done dying yet. After the stars die, matter itself starts to break down. Not immediately. This takes time, a lot of time. We're talking trillions upon trillions of years. But it's inevitable because of black holes. Black holes are the universe's ultimate predators. They grow by consuming everything around them. Stars, planets, gas, dust. Even light can't escape once it crosses the event horizon. And after the stars die, black holes keep growing, slowly, patiently, swallowing dead stars and planets that drift too close. In 10 to the 20 years, that's 100 quintillion years, Galaxies start to dissolve. Stars that have been orbiting galactic centers for billions of years eventually drift away. Some get ejected into intergalactic space. Others spiral inward and get consumed by the supermassive black holes at galactic cores. Our galaxy, the Milky Way, has a black hole at its center called Sagittarius A star, 4 million times the mass of the Sun. Right now, it's relatively quiet. It occasionally swallows a star or a gas cloud. But in the deep future, after the stars die and galaxies fall apart, it will feast. Every dead star in the Milky Way will eventually either escape the galaxy or fall into that black hole. The same thing happens in every galaxy. Supermassive black holes grow. They merge when galaxies collide, and over incomprehensible timescales, they consume everything. Planets disintegrate from radioactive decay. Dead stars crumble as atomic bonds break down. Even objects that seem stable, like diamonds or iron spheres, eventually fall apart, as quantum tunneling allows atoms to rearrange and decay. There's another process at work here: proton decay. This is theoretical, not yet proven, but many physics models predict it. Protons, the particles that make up atomic nuclei, are not actually stable forever. They have a half-life, an incredibly long one. Estimates range from 10 to the 34 to 10 to the 40 years. But if protons decay, then all matter eventually disintegrates. Imagine a chunk of rock floating through space in the dark era. For trillions of years, it's intact. Then, one by one, its protons decay. Each decay releases a tiny flash of energy. Over 10 to the 40 years, every proton in that rock decays. The atoms fall apart, the molecules disintegrate. What's left? Nothing. Just free electrons, positrons, and radiation scattered across space. If proton decay is real, then everything in the universe, every planet, every asteroid, every dead star, eventually dissolves into a thin soup of elementary particles and photons. Matter as we know it ceases to exist. The universe becomes a sparse fog of radiation and charged particles, spread thinner and thinner as space continues expanding forever. But that's not the end, because black holes are still there, and they're about to die too. Stephen Hawking discovered something shocking in 1974. Black holes aren't truly black. They emit radiation. Not from inside the event horizon, that's impossible. But right at the boundary, quantum effects create particle-antiparticle pairs. One particle falls in, the other escapes. From the outside, it looks like the black hole is glowing. The glow is incredibly faint. A black hole with the mass of our sun would have a temperature of 60 nanokelvins. That's 60 billionths of a degree above absolute zero, colder than the cosmic microwave background radiation filling space. So right now, black holes are actually absorbing more energy from the universe than they emit. They're growing, not shrinking. But the universe is expanding. The cosmic microwave background is cooling. In about 10 to the 20 years, the background temperature drops below the Hawking temperature of stellar mass black holes. At that point, they start losing mass, slowly at first, then faster. The smaller a black hole gets, the hotter it becomes. The hotter it becomes, the faster it evaporates. This creates a runaway process. A black hole with the mass of the sun takes 10 to the 67 years to completely evaporate. A supermassive black hole like Sagittarius A star takes 10 to the 100 years. But eventually, every black hole in the universe evaporates completely. The final moments are spectacular. As a black hole shrinks to microscopic size, its temperature skyrockets. In its last second, it releases more energy than a supernova, a brilliant flash of gamma rays and particles. Then nothing. the black hole is gone, converted entirely into radiation according to Einstein's E equals mc squared. When the last black hole evaporates, around 10 to the 100 years from now, the universe enters its final era, the dark era. No stars, no planets, no black holes. Just photons and a few stray particles spreading farther and farther apart as space continues expanding forever.
Transfer. Thermodynamic equilibrium. Heat death. The universe still exists, but it's functionally dead, an infinite void growing colder and emptier for eternity. But some physicists think there's one more death, one final ending beyond even this. This is where physics gets truly speculative, but it's based on real theories about the nature of space and time. We think empty space, what we call the vacuum, has energy. This is dark energy, the force causing the universe's expansion to accelerate. Right now, dark energy is constant. It doesn't change. It just pushes space apart at an ever-increasing rate. But what if it's not constant? What if the vacuum we're in right now isn't the true vacuum? What if it's a false vacuum, a temporary state that will eventually decay into something lower? Think of a ball sitting in a bowl on a table. It's stable. It sits there. But if you shake the table hard enough, the ball might jump out of the bowl and fall to the floor. That's a lower energy state. The floor is more stable than the bowl. The vacuum of space might be like that ball, sitting in a temporary equilibrium, waiting to decay. If the vacuum decays, it doesn't happen gradually. It happens in a bubble. Somewhere, randomly, quantum fluctuations cause a tiny region of space to drop into the true vacuum state. That region expands at the speed of light. Inside the bubble, the laws of physics are different. Particles have different masses, forces have different strengths. Chemistry doesn't work the same way. The bubble wall destroys everything it touches. Atoms ripped apart, particles converted into different particles, reality rewritten. And there's no warning, no way to see it coming, because the bubble wall moves at light speed. The light carrying information about its approach arrives at the same instant the wall does. This is called vacuum decay, and if it's possible, it could already be happening somewhere in the universe right now. We wouldn't know until the bubble reaches us, and when it does, everything we are, everything we've ever known gets erased and rewritten in a fraction of a second. If vacuum decay happens, it could occur tomorrow, or it could wait 10 to the power of 10 to the power of 120 years, a number so large it's beyond human comprehension. 1 followed by 120 zeros, then raise 10 to that power. That's longer than the black hole era by a factor so vast there's no analogy. If every atom in the universe were a second, that wouldn't even come close. But even if vacuum decay never happens, there's still a final problem: quantum fluctuations. In an infinite amount of time, anything that can happen will happen, including incredibly rare events, like random quantum fluctuations assembling into conscious observers, Boltzmann brains. Disembodied minds that pop into existence, have a single thought, then dissolve. In the far future, after 10 to the power of 10 to the power of 50 years, Boltzmann brains become more common than real observers. The universe fills with these random, temporary minds, flickering into existence and vanishing. Reality becomes noise, structure becomes illusion, and even the concept of cause and effect breaks down. This is the heat death endpoint, not a dramatic explosion, not a collapse, just an infinite expanse of empty space, occasionally producing random fluctuations forever. No meaning, no purpose, no change. Just existence without content. The ultimate cosmic silence. 3 deaths. First, the stars die, plunging the universe into darkness in 100 trillion years. Second, matter itself disintegrates, dissolving into radiation and leaving only black holes in 10 to the 40 years. Third, the black holes evaporate, leaving an empty void in 10 to the 100 years. And if the vacuum is unstable, reality itself could collapse at any moment, rewriting the laws of physics in a bubble expanding at light speed. This is the fate of everything. Not a theory, not speculation, physics, thermodynamics, the inevitable consequence of a universe governed by entropy. Everything that begins must end. Every structure must decay. Every star must die. And eventually, even space-time itself will become so dilute, so cold, so empty, that nothing meaningful can ever happen again. The universe has an expiration date. We're living in its first moments, the brief, bright era when stars shine and life is possible. Enjoy it while it lasts. If this existential dread awakens something in you, hit that like button and subscribe to Space and Scale. Next time, we're exploring what happens if the universe is actually a hologram. The evidence will blow your mind. See you there.